allocating capacity.
Yes, I will talk about how to allocate capacity in bike share systems. And I will be talking about a model that David already introduced this morning. It's a model of one bike share station where people put bikes in or take bikes out of the station. It's been introduced by a couple of different authors. And it was really initially introduced to capture how many bikes should be in a station at the beginning of a rush hour. So we want to minimize the number of people that are, like the number of customers that are unhappy at the station. And when is a customer unhappy? In one of two cases, when the station is full and she tries to put a bike into the station, or vice versa, if the station is empty and she tries to take a bike out of the station. Now, we assume basically that the customers appear probabilistically with per sound rates, and the expected number of customers that are annoyed, we can then write as the expected number of minutes that the station is empty, multiplied by the out rate, plus the expected number of minutes that the station is full, multiplied by the in rate to the station. And David talked this morning about this being a convex program that we could optimize over the bikes. And he also talked a little bit about the fact that even if we took the capacity of each station as a variable, we would still have a convex program, and we could find the optimal allocation over the entire system of bikes and dogs. And if we were able to put every dog and every bike in the system according to the solution that we get, we would then be able to say, over the next rush hour, we will minimize the number of customers in the system that will be annoyed. This is the point where I'm sort of deviating from what David was doing, because I'm saying that this is not really the right objective. Because we cannot actually optimally allocate the bikes before every rush hour. The reason being limited rebalancing. So instead, and that's explained on my poster, and I think I've run out of time very fast in just 2 minutes. Instead, we do a steady state analysis where we consider the number of bikes simply given by the demand and don't consider rebalancing, and think about how many dogs should we have at each station. Thank you.
Daniel.